Okay, so we've gotten 2/3 of the way through, a little over 2/3, right? Let's see. I'm going to change this setup just a little bit here because I think I can just restart the right. If I exit out of this, I have a terminal like this. Make this 100 wide to be so we don't have dealing with things scrolling off the edge of the screen here. I have a column at 80. Do we need tmux then? I don't think so. So let's open up a new terminal to run the watch, and this will give us a little more room to see what the watch is. Doc dev rustlings rustlings watch. So it should still. Oh, it's got to go through all of them. Okay. So let's quit out of this, quit out of tmux, and just go directly to, I think it was tests, but let's see. Oh, it's exercises, right? Okay. This should get there pretty soon. We're at 65. Okay, so we have a... Let me do this over here on this other screen. There we go. Okay, should have set up before. All right, so let's fix this test. I think it was just straightforward. We just had to put a true in there. This test has a problem with it. Make the test compile, make the test pass, make the test fail. Well, we can make it fail by putting a false in the assert, right? And then it should compile and fail, right? And if we put a true, it should compile and succeed. Okay. Test 2. Missing tokens in the macro arguments. Right. So this is just showing how equal works. We can just add a couple of tokens in the macro arguments, get it to fail, get it to pass, and go to the next test. Okay. Test 3. This test isn't testing our function. Make it do it such a way that the test passes. Then write a second test that tests whether we can get the result we expect when we call is even 5. Okay. So, oh, they already have the outline of the test. Okay, so is true and even, so we can just say is even 10 true, and that should pass this test. Oh, assert EQ. I guess we don't need to assert EQ if we can just, if it's returning a Boolean. And then we can just say assert not is even 5. That's probably the simplest, right? Yeah. Okay. Oh, we're in. That was it for tests. Okay, so now we're into lifetimes. Lifetimes 1. Rust compiler needs to know how to check whether supplied references are valid, so that it can let programmer know if a reference is at risk of going out of scope before it is used. Remember, references are borrows and do not own their own data. What if their owner goes out of scope? Okay. Okay. So, I think we're just looking to make sure that the lifetime of the input parameter is the same as the lifetime of the output parameter. And that's what they're suggesting here, is just come up with a generic, or not a generic, a specific lifetime that can be both X and Y. So both X and Y have the same lifetime, and now we know what lifetime to return because there is only one lifetime to deal with. Otherwise, X and Y could have different lifetimes, so we don't know what the lifetime of the return value is. But if we force them all to be the same lifetime, like this, right, then the compiler won't complain. And I'm just doing a little bit of grammar editing because that's the way I am. Oop. Oh, duh. You don't do it that way. Like this. I don't know what I was thinking. I just did a paste. Yeah. So the compiler actually said what to do. We did what the compiler said to do, and unsurprisingly, the code works. All right, lifetimes 2. So if the compiler is just validating the reference passed to the annotated parameters in the return type, what do we need to change? Okay, I see. I'm not sure what they're trying to show here. I mean, you can see that, right, the lifetime of string 2 is shorter than the lifetime of string 1, right? Because string 2 drops out of scope here. So if result happened to get string 2, it would no longer be valid by the time you got to this final line. So what we would have to do is change lifetime of string 2 to be over here. Or could we also do this? Let's see. No, because I guess you can't return that from this. I thought this would move it into here, but not. That's not the case. So we could do that, but then there's no reason to have the scope, right? I wonder if there's some other approach they're looking for. Let's take a look at the hint. Oh, yeah. So that's all they're saying is moving it out of the scope. Okay. Good enough. Lifetimes 3. Lifetimes are also needed when... Oops. I meant to highlight it. Lifetimes are also needed when structs hold references. Okay. Right. So that means that this would have to have a lifetime that both of title and author get. Yeah. So that's what that is. What else we got? Lifetimes? Oh, no, we're done with lifetimes. Okay, good. Let's go to iterators. So we've learned everything we need to know about lifetimes now. Iterators 1. Make me compile by filling in the question marks. When performing operations on elements within a collection, iterators are essential. This module helps you get familiar with the structure of using an iterator and how to go through elements within an iterable collection. Let my iterable fav fruits equals something. So we're just looking at saying my fav fruits.iter. Banana, custard apple, avocado, peach, raspberry, and none. Okay. Some. This will be some peach. And then none. Right? Is that all we need to do? Oh, I missed a close somewhere. Line 19. Yep. Okay. That wasn't too bad. What's next for iterators? Iter 2. Step 1. So first, in this exercise, you'll learn some of the unique advantages that iterators can offer. Follow the steps to complete the exercise. Step 1. Complete the capitalization first function. Capitalize first, input string is string, let mut c equals input chars, match c next. Sum first is a char, and we can say first to upper, right? But we need the rest of the string. Or can we just, isn't there a, oh, I have this thing here. There's a string. There might be a to initial upper or something like that. This is the whole string. Right, we take a stir. Oh, we take a self. Yeah, on a stir. We take a stir and we return an uppercase, fully uppercase stir. There's make ASCII lowercase and make ASCII uppercase. I don't know if there's a, let's see. No, I don't see a initial uppercase. But we're supposed to be testing, we're supposed to be doing iterators, right? I mean, we kind of are here, right? So that we're doing a C next. If there is no character, then we just return a new string. We can say first to uppercase plus whatever, input 1 dot dot. Let s equals string from. Can I do that? Let me do this. And then we can just append the rest of it. The trait from to uppercase. Oh, right, because to uppercase is an iterator next on wrap. Yeah. And then we just say s dot push stir. Oh. Oh, okay. I guess we could say also while. If we're going to use the iterator, let some equals c dot next, s dot push c h, and then we can just return s. Or we could say string new. Yeah, no, this is right. This works. Okay, so we did step 1. Okay, and now step 2 I think we did step 1. Step 2 is apply the capitalized first function to a slice of string slices. Return a vector of strings. Okay. So this must be the return value. Let vec equals, let's just say vec new for w in words val.push, and it was just called capitalized first w, and then red val is the return value. Okay, let's see if that compiles. And we're using an iterator here, so this counts as an iterator solution. All right, step 3, apply the capitalized first function again to a slice of string slices. Return a single string. Okay, so we're going to do the same thing, except instead of let val is vec new, we're going to say string new. And then we're going to say for w in words, ret val not push stir, capitalize first w, and then return ret val. Okay, and that failed. Expected stir, oh, as stir. Yeah, all right, that was fun. That was Iterators 2. Iterators 3. Iterators 3. This is a bigger exercise than most of the others. You can do it. Here's your mission, should you choose to accept it. 1. Complete the divide function to get the first 4 tests to pass. 2. Get the remaining tests to pass by completing the result with list and list of results function. Okay. So what I'm going to do is I'm going to just move this down here so I have access to it easily, because I want to make this taller so I can see a little more of the code. I'm not used to working with such a large font, but I figure it's easier for streaming and YouTubing. All right. Complete the divide function. So where's the divide function? Here it is. Calculate a divided by b if a is evenly divisible by b. Otherwise, return a suitable error. Okay. So you have not divisible error, and we pass in the dividend in the divisor. Okay. So we want to see if a is evenly divisible by b, then we're going to return the I32 of a over b, right? Else, we're going to return an error of division error. Doesn't say anything about 0 yet. Oh, it says return a suitable error. Okay. So we got to actually check for b equals 0 first. Match b. 0. Results in error. Division error. Divide by 0. And it says x if a mod b equals 0. Then we're going to return OK of a over b. And in all other cases, we're going to return, actually, we don't need x either. In all other cases, we're going to return error, division, error, not divisible. And then we just have to create a new struct, not divisible error, dividend a, divisor b. Right? Oops. that looks right. So we first come here, and if it's 0, we hit the divide by 0. If it's anything else and A is divisible, evenly divisible by B, then we're going to do an OK of A over B. Yeah, this looks right. Okay, so we did I think we did step 1 here, complete the divide function to get the first 4 tests to pass. Now these tests are running in any order, so we can't look at the first 4, but right now 6 are failing, so we should be down to 2 failing if we got this right. Yeah, so just these 2 tests fail. Okay, test result with list and test list of results. And that's what we need to do. Get the remaining tests to pass by completing the result with list and list of results functions. All right. Oop. Complete the function and return a value of the correct type so the test passes. Let division results number into iter map divide n27. Desired output is OK 1, 11, 14, 26, and 3. Oh, okay. So this is a result of vec of I32 or division error. Is that all we need to do? Result with list? Nope. Oh. I guess, can we just question mark this out? And then this returns the vec this way. Cannot use the question mark operator in a closure that returns I32. Oh, collect vec I32. Nope. This function should return a result or option to accept question mark. It does return. Oh, is this where I have to do like a map error? Huh. Okay, so this is interesting. Oh, right. This needs to be okay of this. I don't know if that'll fix it. No, it won't. This function, this whole function here, this closure, needs to return. This function needs to return a result or an option. So you can't break out of a map this way. So let's take a look at map. Map return error. Rust. Yeah. Let's see what they got here. Map, find, collect. Result is this. Oh, I see. It returns result implements from iterators, so you can move the result outside and iterators will take care of the rest, including stopping iteration if an error is found. Oh. Okay. So can we just do this? No. Okay, but wasn't iter map find collect. Can I? So if I give it a type, then maybe that'll work. Let's find out. Just looking at this here. And we give this a result of vec I32 or division error. Oops. And then we're not just collecting I32, we're collecting either one. Oh, no, I can't see. Okay. And now we're going to return a result. This result is going to be exactly what we're passing back. Okay. So let's try to clean it up then. Can I do that by saying result vec I32 division error here and get rid of this line and this line and the semicolon. And I'm missing a angle. Does that work? Yes. Okay, so that's a little bit better. Very good. Okay, so I learned something. Complete the function and return the value of the correct type so the test passes. So what's the difference here? This is a list of results. Oh, this is a list of all the OKs. So is this just collecting? I wonder if I can say that, right? Oh, I always do that wrong. Collect result of vec of result. Oh, can I do that? Can I say a collective result of I32 or division error? Oh, and then we're not returning it. Oh, right. So this is going to be a vec of result of I32 and division error. Something's wrong here. Expected a colon colon. On line 48. No. 48. I must have typed 38. Okay. Expected colon colon. Oh, this. Maybe. Yeah. Yeah, okay. So that's all we needed to do. So we can either collect it as just a basic vector, or we can collect each of the results and get OKs and failures, I guess. It'd be nice to see a failure in there. See if I throw a 12 in there, what happens. We do get the error shoved in there. 12 divided by 27 is not even. Okay. Let's get that to pass again. All right, that was good. And now, what's next? Iterators 4. Factorial. Complete this function to return the factorial of num. Do not use return. Try not to use imperative style loops, additional variables. For an extra challenge, don't use recursion. Execute Rustlings, hint, iterators. Don't use recursion. That was the first thing I thought of. Right. Because we can say if num is less than 3, then we're going to return num. Else we're going to return, else we return factorial of num minus 1. Right? Ooh, factorial of 0 failed. X if x is less than 3. X. Otherwise, it's going to be anything else is the recursion. Although I think that x is going to be oh, right, no. Let's just do that. Yeah. So this works, but this uses recursion. There's a way to do factorial without recursion and without loops. Okay. How would you write a non-recursive algorithm to calculate factorials without... Oh, I guess imperative style loops. So we could use an iterator to iterate down. And just multiply all the numbers together. As written, this would actually be slower. Yeah. Okay. So I think that would be interesting. So can we iterate? Can we create an iterator? Rust. Iterate numbers reverse. Range and reversed range. So I could do this, right? This is the real answer. What we can do, let range is equal to num 1 dot dot num rev. Right? I can do that. Oh, U64 is not an iterator. Oh, I have to put it in parens. Right? Okay. So then we can just start multiplying. Using a fold. Range dot fold 1 AB times B. I've forgotten how to use folds now. I think it's yeah, the initializer, which in this case is 1 since we're doing multiplication. And the closure with 2 arguments, the accumulator and an element. The closure returns the value of the accumulator. Right. So will this actually run it? Or do I have to collect? I don't have to collect. And actually, we don't need to do it in reverse order, right? It doesn't matter what order you do it in. I got 6 instead of 24. Oh, because I didn't do equals. So I should be able to say 1.num, 1.out equals num. Actually 2, because we're putting a 1 in there already. Okay. So that's my answer. with no imperative style loops, no extra variables, except this kind of counts as an extra variable. And I could change that with an if statement, right? A chained if-else statement, but this is cleaner, I think. And then for an extra challenge, don't use recursion. So I didn't use recursion. I figured it out without it. Yeah, I think that's pretty clean. I can't think of a way to clean that up anymore. The only thing to add would be to check for overflow, but I don't think that's the point of this exercise. So I'm going to move on. Iterators 5. Let's define a simple model to track Rustlings' exercise progress. Progress will be modeled using a hash map. The name of the exercise is the key, and the progress is the value. 2 counting functions were created to count the number of exercises with a given progress. These counting functions use imperative-style for loops. Recreate this counting functionality using iterators. Only the 2 iterator methods, count iterator and count collection iterator, need to be need to be modified. All right, so we're going to modify count iterator, which is right here. Oh, and it said to do. Map is a hash map with string keys and progress values. Map variable 1 complete from string none. So is this just counting? Two counting functions are created to count the number of exercises with a given progress. So we're given a value of progress, and we're going to count how many exercises there are with that given progress. And we don't want to use for loops. These counting functions use imperative style for loops. Well, not yet, right? Count iterator doesn't anyway. Count collection 4 does. Count collection iterator does. Oh, I see. So count 4. So we would just have to do count 4 here, but using iterators. Okay. So we just use a filter on it. Map.iter. And we get a key value tuple out of that. Fold 0, A and B. We don't care about the keys, so we can say iter values, right? Now B is going to be the value, which is going to be a progress. A plus equals B is equal to value as U size. Is that it? So we're just incrementing by 1. Oh, maybe it's just values. No implementation for progress equals progress. Oh, okay, they do have partial equal, but we can deref it this way. Nope. Expected U size found. Unit? Oh, right. It's not A plus equals, just A plus. Okay, so that passes those first 2. So now we just need to, let's get rid of the comments here. And now we'll do a count collection iterator, which does this. For map and collection for val and map values, if val equals value counted plus equals 1. Oh, now it's in a vector. I see. So we're going to count for every entry in the vector. So this is where we're going to iterate on the vector, right? Map, or collection, iter, fold 0, AB, A plus, B dot, and then it's just A plus count 4B. Right? Or count iterator B. Oops. Help add semicolon here. Oh, we don't need the to do. Value. Forgot the value. Yeah, okay. I don't know if they were wanting me to redo the logic here or simplify the logic somehow, but these seem to be the best way to approach it. Okay. That's iterators 5. We're now on box 1. At compile time, Rust needs to know how much space a type takes up. This becomes problematic for recursive types, where a value can have as part of itself another value of the same type. To get around the issue, we can use a box, a smart pointer used to store data on the heap, which also allows us to wrap the recursive type. The recursive type we're implementing in this exercise is the cons list, a data structure frequently found in functional programming languages. Each item in a cons list contains 2 elements, the value of the current item and the next item. The value of the current item and a link, I guess, to the next item, maybe would be a better way to phrase it. The last item is a value called nil. Step 1. Use a box in the enum definition to make the code compile. Step 2. Create both empty and non-empty cons lists by replacing unimplemented. Note, the tests should not be changed. That's an easy way to make the test pass, right? So what are we doing? We can't use list in here. We have to use box list, right? And in fact, the compiler is saying that right here. All right, so now it compiles, but both our tests fail. So create both empty and non-empty cons lists by replacing unimplemented. So create an empty list. Just say, I can say list nil. Yeah. And create a non-empty list. So we can say list cons of 3 and box new list nil. Yeah. Okay. What does the test look like? Yeah, so it's just asserting that it's list nil. And this is just asserting that create empty list is not the same as create non-empty list. All right, fair enough. Okay, that's box 1. Is there a box 2? And what else is there to know? Okay, arc. Arc 1. There is only arc 1. In this exercise, we are given a vec of U32 called numbers with values ranging from 0 to 99. We would like to use this set of numbers within 8 different threads simultaneously. Each thread is going to get the sum of every 8th value with an offset. The first thread will sum 0, 8, 16, and so on. Second thread will sum 1, 9, 17, then 2, 8, 2, 10, 18, and so on. Because we are using threads, our values need to be thread safe. Therefore, we are using arc. We need to make a change in each of the 2 to-dos. Make this code compile by filling in a value for shared numbers where the first to-do comment is Okay. And create an initial binding for child numbers, where the second to do is. Try not to create any copies of the numbers vec. So where is shared numbers used? Oh. Okay, and then where's child numbers? Child numbers is actually used here as an iterator. But I think this needs to be based on shared numbers, right? So are we just creating a vector of arcs here based on the numbers? I actually don't know what they're looking for here. Let's go to the hint. Oh, we're going to have to use arc and thread. They already have thread here, so we're going to be using arc. That's fine. Make sure numbers be an arc from the numbers vector. Okay, so we can just say arc new numbers. And that gives us shared numbers. And then child numbers should be a clone of the arc of the numbers instead of thread local copy. Oh, I see. So it's like RC except... Yeah. We don't know if these numbers are correct because they didn't put anything in here. But I guess we're going to assume they are. It would be nice for them to have a test. Shushak says you can use shared something, not clone. Oh, that's true. Yep, either way. Yep, okay. Okay, so that was arc. And there's only arc. So now we're going to do threads. And there's three in the threads. We're getting close to the end, right? Got, what, 14 more to go? Well, 15 counting this one. Okay. This is just, there's no explanation here. To do, a struct is returned from thread spawn. Can you use it? Consider giving handles a type. What do they want me to do here? To do for handle and handles. I guess we can look up how threads work here. I'm guessing we want to join, to do a join here. Right, maybe that'd be a good example. Oh, I see what you're saying. Yeah, so Shushak says probably push the threads into the vec. So we have a vec here, and it's mutable, so we can just push the threads. Right, so we do a spawn, and we get a thread back, and we can just create the thread that way. Okay, that makes sense. I haven't used threads in Rust yet. So, and then to do, so we want to do a join. Computation join unwrap. So on each handle, we're going to do a handle.join. Do we have to do an unwrap? If we don't care about the result, we just care about how many threads were completed. Here we're going to panic if it fails. I guess we could do that. But this should work without a whoops. I hit Control D over here. Yeah, so it should work. It works without an expect. Okay. That works. Thank you, Shushak. All right, so threads 2 is next, right? Building on the last exercise, we want all the threads to complete their work But this time the spawn threads need to be in charge of updating their a shared value job status job completed. And this time we're going to use an arc. So they're all going to share this arc. We're going to spawn here. You must take action before you update a shared value. What's it? Arc? Is there a lock function on arc? Oops. We can clone it. So we can clone it into, oh, thread spawn move. Is there a move on there? Yeah. And that prints 5. Fetch add 1. And that's val. So is that a function on? Maybe we can do a get mute. I'm not sure what this fetch add is. Maybe that's something here. Returns a mutable reference into the given arc. If there is no other arc or weak pointers to the same allocation. Returns a none otherwise because it's not safe to mutate a shared value. Is there a way to do it to block waiting? Shurshak says fetch add is for an atomic U32. Okay. So I don't want to put a loop in there. I just want to be able to increment strong. Okay. Increments a strong reference on associated with the provided pointer by 1. Pointer must have been obtained by arc into raw. The associated arc instance must be valid for the duration of this method. This is unsafe. I assume we're not trying to do unsafe code at this point. And get mute just returns a none if it can't. Pin? No, that's pinning it in memory. Gets the number of strong pointers to this allocation. Unwrap or clone. So there should be something that allows us to modify the arc, right? Weak T does not, okay. Sharing some immutable data. This is immutable. Sharing immutable atomic U size. I'm assuming we're not going to add an atomic U size to this thing. I think they just want us to do it this way, right? I didn't think that they wanted me to add that. Oh, I guess they did. They did want me to add a shared reference to immutable data. We want to change the number of jobs completed. So we can take a look here. Yeah, so we just put it in a mutex. Okay. All right. I know mutexes. And we just lock it to gain access to it, right? And then increment it. Right. So we can just use this code essentially. Let handle equals thread spawn, handles.push. So we just put this in a mutex. Like that. And then here we sleep, and then we're going to do a and we're getting status. Oh, we can't use that. status lock unwrap lock dot jobs. Oh, I see. Status shared. That's what we're trying to do here. And then here, print the value of the job status, jobs complete. Did you notice anything interesting in the output? You have to join all the handles. Maybe? Let's find out. Lock. Unwrap. Okay, let's see how badly this blows up. Oh, I see. Oops, let's call this, I misread this, my status, here we go. Like that, right? Look at that. You have to join all, you have to join on all the handles. Maybe, I don't know. I mean, I'm seeing 10s throughout here. So, I mean, it would make more sense to do this, right? Wait till they're all joined and then print out how many completed. SureShack says you can use same variables because in Rust variables can be shadowed. Yeah, that's true. You can do that, right? And that should still work. Okay. That was threads 2. Let's take a look at threads 3. Not a lot of hints here. So we're just trying to get this code to compile. We have a sender and a receiver. Where's RX? RX is here. Okay. And value used here after move. Oh, I see. So this MPSC is being sent in here. Where? Or does this move just move all the variables that are in scope? Is that the way the move works? So in order to solve this, do we need to make this an arc as well? SureShack says moves only the variables that are used inside the closure. So TX is used inside the closure. So that got moved. Okay. So if we make it an arc, we should be able to clone it, right? And then we can say arc new here. Oh, you can clone senders? Without needing an arc? Or I can say let first equals tx clone. Taking a while to run. Oh, I guess it's doing some delays in there. Okay. So all I have to do is clone to get it into the here. Okay. MP and MPSC means multiple producers. Okay. I keep losing my window here. Does this come from a crate? No, it comes from the standard library. Okay. And that's what this says right here. Just do a clone. Okay. Very cool. What's next? Yeah, NTX is MPSC sender. Yep. Got it. I think we're getting close here. We're on 80. Okay, so now we're in macros. Check out my macro. My macro. Cannot find function my macro in the scope. I don't know macros, and I've never really written the macros. I've copied, pasted them. Let's go Rust macro. Hopefully we're not going to do proc macros here, right? So what am I doing wrong? Do I have to put the macro export at the top of it? Is that what's missing? Nope. Oh, I need the bang there. That's what I'm missing. Yeah, that's what was missing. Duh. Sure Shuck says macro is probably like PHP or Rust. Moosex. Oh, sorry. Hi. I didn't realize you were here. Your color is the same as Shurshack's, and I didn't. You were streaming yesterday. For me, it was yesterday evening. But I didn't hear any audio, so I wasn't sure if you were meaning to stream or actively engaged, or I wasn't sure. I said hi. Okay. Do you have a mic? Are you testing your stream setup? Yeah. So the way I tested my stream setup was I used OBX and I just clicked start recording, and that does most of the testing for me. All right, so we got macros too. Cannot find macro, my macro in the scope. Unused definition, my macro. So does this just mean that the macro has to be defined before? Yeah, that's interesting, because everything else in Rust, it doesn't matter what order you define things in. But I guess the macro system does care. Mousek says, I have a single screen and need to check how often personal information shows up. Yeah, so I created a brand new identity. So all my personal information is in a different user. So that simplified that stuff. All right, so now we're in macros 3. So this means I just have to use macro. Can I say macros this way? Couldn't find my macros in macro. Make me compile without taking the macro out of the module. Oh, there's a thing you have to do to say, yeah, is this where we use macro export? Nope. Actually, definition of the Beck macro standard library includes codes. Okay. Procedural macros. How to write a custom derived macro. Yeah, so this is, I thought, find a macro, use macro rules construct. But it doesn't say how to deal with it in modules. The macro export annotation indicates this macro should be made available whenever the crate in which the macro is defined is brought into scope. Do I not need the scope then? Yeah, okay, so that was a mistake. Okay, so macros don't need scoping. I guess it just exports it into the current whatever scope. Yeah, and come to think of it, I've never seen a macro before use a namespace specifier, right? Shurshak says, I don't like such shenanigans. Yeah, namespace pollution, but maybe that's why it's got the bang on there, so that we don't have to. We know where it's coming from or where it's going to. All right, here's macros 4. No rules expected this token in macro call. Val exper. No rules expected the token open paren. So this is a nothing, and this is an exper, right? So the first would match the first one, and the second one would have the second one. Mousak says log has a lot of macros that are exported and do the right thing, i.e. log : info bang and log : warn bang. Oh, huh. Okay. Is there a way you can export it with? I don't see anything here. That indicates how that works in, as a submodule. Shurshak says no comma needed in macro rules definitions. You mean like here? No rules expected this token in macro call. So I guess it wasn't expecting a comma there. But this looks like I need to put this in parentheses. Or have a $sign in front of it. Like that? No, it didn't like that either. There is a semicolon here. I could try semicolon. Nope. I'm not sure. Let's see what the hint says. You only need to add a single character to make this compile. The way macros are written, it wants to see something between each macro arm so it can separate them. Alright, well, I tried a comma and I tried... Oh, but I left this in, didn't I? Yeah, so it needs a semicolon to separate them. Got it. Oh, and then we have... Shurshak has a must by example here. Each arm must end with a semicolon. All right. Continuing to learn. This is good. That's the whole point of doing this. I'm done with that. Macros 4. And now we have Clippy. I'm very familiar with Clippy. I use Clippy a lot. Clippy tool is a collection of lints to analyze your code so you can catch common mistakes and improve your Rust code. For these exercises, the code will fail to compile when there are Clippy warnings. Check Clippy's suggestions from the output to solve the exercise. Error. Approximate value of F32 constants pi found. Consider using the constant directly. I did not know Clippy did that. Does it? How close does it have to be? And what is it doing to make the code fail? Here's Clippy 2. Compiling of this failed. Please try again. Oh, I guess we're just looking at the output of Clippy. Okay, that's fair. For loop over option, which is an option. This is more readably written as if let. Okay, so let's look at Clippy 2. For x and option, x res plus equals x. Oh, it's over a single option. I see. So we can say if let sum x equals option this. The note tells you that the code is compiled with -d warnings that transforms Clippy warnings into compilation errors. Oh, okay. I didn't read the whole note. Let me read it this time. We have Clippy 3 now. So now we have 5 errors. Okay. Clippy 3. So the first one is we're missing a comma here, right? And here, I guess. The next one is we're doing an my option. This call to unwrap will always panic. Oh, because of this check. So I guess if we want to leave that unwrap in there, we change this as sum. Then we have this error down here. Let's swap these two. Help try standard mem swap. Yeah, this doesn't swap the two. You need an intermediate in order to do a swap, but we can do that. Standard mem swap. And then we have this let binding has unit value. Omit the let binding. If I omit the let binding, then we don't have a variable, right? But I think we can do this, right? It's not really empty. It's not an empty vec. Why are we doing it? And what does resize do on the vec? Resize the vec in place so the len is equal to new len. Okay, if new len is greater than len, the vec is extended by the difference. New len is less than len, the vec is simply truncated. The method requires t to implement clone in order to be able to clone the past value. If you need more flexibility, okay, so it's saying resize it to 0 using 5 as the value type. To extend it if it were extended. Okay, so we'll try that. Mousex says some Clippy lints are errors by default. Yeah. Oh, yeah, so we can just do try if let sum blah equals my option. I guess. So all we're doing is doing the unwrap, right? Statement with no effect. And this is unit. So, but we can, I guess we can just print it. Just to do something with it. Right? And then we have empty vec. Or you can empty the vec with clear. That's true. The code is compiling and Clippy is happy. Okay. What's next? Okay, like the Clippy stuff was kind of amusing. Using as. Typecasting in Rust is done via the usage of the as operator. Please note that the as operator is not only used when typecasting, it also helps when renaming imports. Right. In fact, we had a module in the last stream which did that with fruits and vegetables. All right. The bug here is we're dividing total by values len, and this is F64, and we need to make this as F64. Yeah. Okay. And now we have from into. The from trait is used for value-to-value conversions. If from is implemented correctly for a type, the into trait should work conversely. You can read more about it. Execute Rustlings hint. Oh, okay. I used the hint. We implement the default trait to use it as a fallback when the provided string is not convertible into a personal object. So by default, people are named John and are 30 years old. Your task is to complete this implementation. In order for the line let p equals person, : from mark, 20 to compile. Please note that you'll need to parse the age component to a usize with something like 4.parse usize. The outcome of this needs to be handled appropriately. Steps. 1. If the length of the provided string is 0, then return the default person. Okay, I guess we're implementing from here. If s.len equals 0, return person default. And that should just work. And then we'll have to handle all the other cases. Split the given string on the commas present in it. There's a split 2, right? Oops, I did the wrong thing. This. And I think, let me look down here. Oops. Split at, split n. An iterator over substrings of a given slave separated by a pattern restricted, returning most n items. If n substrings are returned, the last substring will contain the remainder of the string. Okay. I guess we don't need that, right? We can just say split at, divide one string slice into 2 at an index. And this is a pattern. Iterator over substring string slice separated by pattern. Right. So we can we can do this. Data equals s.split and a comma dot collect. And if we make it a vec of stir, can we do that? What do we have here? This is a vec of ampersand stir. I guess. Let's see if that builds. This will at least compile, right? And we can see, oh, we only have one failing test. So that's all we need to fix, is this one failing test. Shrishak says, you don't even need collect calling next should work. Well, I think next will only give us the next one. But you're right, we can make this as an iterator. right? And then we can just say let name equals iter next, unwrap. And then age, stir, right? And then we can say person. Is there a new on this? No, it's just a default. Okay. So we can say person name. It's a string. So string from name. And then age is going to be age stir. If this fails to parse, what do we do? Split this given string's uncommon as present in it. Extract the first element of the split operation and use it as the name. If the name is empty, then return the default of person. Ah, okay. If name is empty. Can you do that on stirs, on stir slices? Okay. Extract the other element of the split operation and parse it into a usize as the age. If while parsing the age something goes wrong, then return the default of person. Okay. If let sum age equals age, then we can just return this. Right? Else person default. Oh, SureShack says by empty the problem even don't use unwrap. Yeah. So we can say if let some name and we can just continue on and just put person default here. And then we can just say return this. Not a fan of this pattern here where we do if let sum and then if let sum. There is the let. They just put something in Rust 162. If let chain. Yeah. They just did that. So you could do this. Epic Blog says let chains. So I haven't tried it yet. Well, let's see this work first. Hopefully this is correct. Let's see what blows up, and then I'll make a let chain out of it. Oh, because this is the result. Can I just flip it to an opt-in this way? Nope. Test trailing comma. Ooh. Test trailing comma and some string. Test missing comma and age. Test missing name. So all those failed. This should have tested missing name, right? We say if let some name is iter next, and if it's none, then we drop down here and return person default. All right, let's take a look at missing name. All right, test missing name, left is quote, quote, right is John. Oh. Mousex says the split will return the whole string if there's no comma in the string. Oh, that's true. That's absolutely true. absolutely is what I meant to say. I don't know what came out of my mouth just now. Oh, split once. That was what I was looking at. Right, so let's do a split once. I think that's what I've used in some Advent of Code stuff. And that way, if split once doesn't have the thing, it'll return a none. Right? Right, and that way the first one will fail. But we're still... Oh, I keep doing that. Oh, yeah, so now we actually have... so we can destructure this now. We can just say name without having to use the iterator. Age stir. Let's let some name equals name. And then we can just do this. Age stir. Right? Oh, almost. Expected option found tuple. Oh, because it's a... I have to do this? Almost. We're still missing this one test, this test missing name. Okay. So test missing name has a comma in it. Oops. Where is it? There's a lot of tests. There. It has a comma in it. So I just need to check that. Oops. There we go. I saw a giant wall of comments and I thought maybe I accidentally flipped into like the docs or something. Okay. So this name we have to check to see if it's not empty. But now I can't do an if chain, right? That's right. We'll say oops. And that was okay. Here's slen is equals 0. And so we can just say if name is empty, then return person default. This probably can be cleaned up a bit. I don't like having these multiple returns here. But the other way to do it is slen is greater than 0, right? Which makes it even more indented. So there's some argument to be made for early returns. You know, you do a bunch of checking at the front. Mousex says, I think let change will work still. So okay, so the way let change work is you can do this, right? But I need to be able to extract the age. Oh, I guess I don't need to make it as a separate. So I can do, oh, can I stick a non-let thing in here? Well, let's do this first. This is a little sloppy, but we can do this. And we don't need to okay it if I just put an okay here, right? And do I have to put the if again or just let? Yeah, okay. So just and let, then this, right? Right. That does not build. Oh, because I'm missing a. Oh, I have an extra open brace now? Somewhere? That's that one, that's that one, that's that one, right? And this is this if let statement here. It's still not formatting it. I'm still missing something. Let expressions in this position. Oh. Rust up. How do you do it? Rust up update stable or something like that? Rust up self update. Oh, yeah, I'm not doing default nightly. Just update should do it. Yeah, because I don't have 162. Oh yeah, and they just released a bug fix version yesterday. All right, let's see how long this takes. Hopefully this will go quickly. Oh, and now I have to I should have done this in a separate window because now I have to restart Rustlings, which has to go through every exercise. Yeah, it's already available. It's in 1.62, which was released not too long ago. Okay, so Rustlings watch. Now we have to watch it go through every exercise. It's too bad it can't do this in multiple cores. Almost there. But this should format, right? This is this line here. Yeah, let's find out. So we're almost there. Let expressions from this position are unstable. Okay, let's take a look at what they're talking about here. Maybe no, I just did the Rust up update, so we should be using the right version of Rust. Mousex says you probably have to have restart Rustlings anyway, so no time's lost. Okay. I would hope that it would just rerun it, but maybe. Yeah, this is a shame because I thought this would work, and this isn't anything special here. If I put this back, let's put this all back, right? This is where I had it working, right? Yeah. Oops. Oh, it's rebuilding everything. Dang it. Okay. That wasn't too bad. Yeah, so this if let works. Let me change this. Right. Let's change this here so we don't have that intermediate step. I can change this to an OK. So this should still work, right? Right. And then the only other thing is let's move this in. And we can change this to a not, right? Make this an even bigger pyramid. Now it still works. Okay, so now all I want to do is take away this if and take away that brace. And this is what fails. Yeah, okay. So I thought we had it working. Let expressions in this position are unstable. And it's looking at this old issue from 2018. And I thought this was what we were doing, was the let chains. Unless this isn't using the latest version. I just did a rust up, so it should be the final syntax. If let equals meta and let okay, let's take a look at Rust 1.62. Oops. There we go. Oh, did I misunderstand? I thought let chains were in 162. Oh, this is 162.1. Here it is. No, I thought let chains were in 162. Okay, I must have misunderstood then. Yeah. When are let chains coming? Oops. Oh, maybe it's in nightly. Releases.rs. Nightly is 164. Oh, maybe that's what I read. Ah. Maybe I read that it was stabilizing and it's okay. All right, so we'll come back to this one when I get there. So let's undo all those changes. And get that to pass. All right. I'm bummed. Now I'm bummed. But we've got to wait a few weeks for this. All right, so next is from stir. This is similar to from into, but this time we'll implement from stir and return errors instead of falling back to the default value. Additionally, upon implementing from stir, you can use the parse method on strings to generate an object of the implementer type. Okay. Steps. 1. If the length of this provided string is 0, an error should be returned. Empty, I guess, right? If s dot is empty, return error. Self. Can I do self error? Empty? Or do I have to put the whole thing in there? Okay, what does person look like? I see. So let's just put a temporary person in here. Name is string from John, and age is 30. All right, just to get it to compile. Oops. Oh, it's an OK. Yeah. All right, so now we just have failing tests. I can live with that. Okay, so that was step 1. We got empty input working. Good. 2, split the given string on commas present in it. Only 2 elements should be returned from the split, otherwise return an error. Okay, so this is where we can also do the if let sum name age equals s dot split once, comma. Otherwise, we're going to return an error. And the error is incorrect number of fields. Bad len. Oh, I forgot. All right. Caleb, thank you for this. Thank you for the raid. Much appreciated. You were working on making games with SDL, right? I haven't tried that. Oh, and thank you for the follow as well. Very, very much appreciated. So how'd the game come along? I know you're rating because you probably have to go right away, but yeah, I'm just curious about the game. Right, so this is step 3. We're returning bad len. So we got a couple more tests passing. Extract the first element from the split operation uses the name. Extract the other element from the split operation and parse it to a usize. So it's exactly what we did last time. Right, so we can just say if let sum age is equal to age dot parse usize. Oh, not sum. Okay. Right. Otherwise, we're going to do an else. If while extracting the name and the age something goes wrong, the error should be returned. Everything goes well. Result of person object. So this should be a parse int error. Right. If we can't parse this, we say error. If I just do it like this, then I can just make them all just happen. Caleb Dev says still learning Rust 2, but I didn't have any Rust issues. Oh, good. That means you're becoming an expert. Self error parse int parse int error. I guess what we could do. Well, that's okay. We got this, right? So if we're able to parse the age, we also want to check the name is empty, right? If name, not name, is empty, then we're going to do this business. Caleb says SDL seems to be okay as well. Yeah, I mean, I play around with a few. I'm in the middle of doing a roguelike, which uses bracket lib, and then so it's a completely different toolkit. Yeah, parse int error is a type. Yeah, so we need to actually get the error from here, right? So let age result. Oh, match age result. No, match age parse, right? Okay, age, do something, and an error, E. And we should just be able to do this, right? And then this is going to be an error, self error. What are the error options here? No name. Okay. Caleb Dev says, I think this exercise I couldn't quite figure out. All right, well, let's see how far I can get with this. Oops, now I need a result, right? So I need to just say, okay, of person, name, string from name, and age. No? Oh, there we go. Ooh, all but 2. Trailing comma and some string. So, if age is empty, we should say we're missing the age, right? I'm doing a bad len, on the trailing comma. Okay, well, let's first take a look at which one is which. Trailing comma. So the right is what we're expecting, and the left is what I'm returning. So I'm returning a parseInt error, invalid digit, because I'm giving it a comma. Oh, and I should be returning a bad len. Okay. Yeah. All right. Thanks again, Caleb, for the raid. MouseX says the issue is the split once is returning a comma as part. Right. Exactly. Okay. So, I guess we have to do it the hard way, right? Let's do a regular split. Let's create an iter. Let's split on comma. And we'll say if there's no name, I'm trying to do this without making it all wacky. So I can say let name is equal to s dot if s dot iter next let some name equals iter next, then it's name. Otherwise we're going to say return error, error self error empty, not empty, no name. So we don't have it or something. Yeah, so we can do that semicolon. This gives us the name. Then we can say let age is equal to if let some age equals iter next. Oops. Then we're gonna just parse out, and we might get an error there. So we can say if let OK age is equal to age dot parse usize. Then we're going to return age. Otherwise, we're going to say parseInt. Oh, here, yeah, we have to do the match again in order to get it. And this will be OK. Age is age. And error E is this. And if we don't get a next age, then we're going to say missing age, right? It's bad len. Is that where we get bad len from? Oops. No. Return. Oh, this has to be return. And I probably have to put it in braces like this. And then this will be return error self error bad len. All right, so that gives us the age, and then we have to say if iter next is sum, return error self error bad len. Right, and now we have age and name, and we can just return the person. Maybe. All but one missing name. Okay. Really close though. We returned an empty name and an age of 1, and that was on missing name. And that was a test I failed last time, right? Oh. Here, if name is empty, return error self error, no name. Oh, we could just say this. No, we have to do it this way. Otherwise it's name. All right, let's see if that works. I'm not thrilled with the way this code looks, but it's doing all the proper error checking. Extracts the name, it extracts the age, and I'm avoiding all the massive indentation that comes from all the error checking. And then at the bottom is when we return the person, which I think is the, you know, if you're going to have a success output, you want that at the bottom, and all the error outputs come in the middle. I'm just looking at it to see if there's a way it can be cleaned up a bit. And we're not seeing anything obvious about how to clean this up. Eric Blog says, in my experience, error handling is 80% of code warts. Yeah. I guess one thing we could do, I don't know if this is cheating. Do we have an impl person? No, we don't. So we could write an impl person and then just create some static functions. Name. Oh, but we need the parse person error. Yeah, that might work. Name check. We want a string or a parse person error. And this will just be this code here, right? If S is empty, return error no name. Is that all we need to do? And then just pass that in. Option. If S is none, then do that. I'm just trying to extract the info. If let name sum n equals, name equals S. We can say if name is empty, return no name. Otherwise, we're going to say string from name. Okay. And then this should allow us to just say let name equals person, name check, iter next, question mark. Maybe like that? Nope. Oh, because I'm still doing self error. I can't type the word parse for some reason, so I'm going to copy paste. Hey Hoff, thank you for the follow. I was hoping this would work. Oh, if is missing an else clause. So, if this fails, then we have to have an else no name, right? Oh, but it's guaranteed to be this. So we don't need to do this if none. We can just do that. Yeah, okay, so that simplifies this, and we can do the exact same thing for age, right? And we can just do person age check and get that, and then put the question mark. And I think that cleans it up. Hey Hoff says, hello, what NeoVim color scheme are you using? I'm using whatever Togglebit did. Let me see if I can get his. I'll put it into chat. toggle byte. So this is what I grabbed this, and I just kind of edited to a few of the keys for my own personal use, but it's whatever color scheme he had set up in there. It's a pretty high contrast one, so I like it for streaming. Yeah, so this is name check, and then we could do basically the same thing for age check, and that way the person handles the code for naming and stuff like that. And all we have to worry about is doing the conversion here. So I should be able to just put this up here for age check. Option stir. And it has a result of a similar result, not the same, because we need to return a use size. So there's that, and then we have the parse person error. Nope, we don't want that. There's a semicolon there for some reason. And then this is just going to be age of person, age check, enter next. And if iter next returns a none here, we're going to return immediately using the comma, so we don't have to worry about, we know we didn't get a none if we got here. So we're not calling iter next on a none return. Still not good enough. What am I missing? Some age is age. We age parse as use size. We return an OK age here. Otherwise, we'll return an error here. Otherwise, it's going to be bad len. All right, let's see what I messed up. Oh, I forgot the close angle here. Yeah, okay. So that simplifies this code a lot, right? We get the name, we get the age, we make sure that we didn't get too many. And all the tests pass. So, and then there's our person. Okay, I like this a lot better. Name check and age check. Good. Oh, I have to delete the I am not done, which is all the way down here for some reason. Okay, that was from stir, and now we're going to do try from into. Try from is a simple and safe type conversion that may fail in a controlled way under some circumstances. Basically, this is the same as from. The main difference is that this should return result type instead of the target type itself. Okay, are we doing persons again? Oh no, we're doing color. Okay, your task is to complete this implementation and return an OK result of intertype color. You need to create an implementation for a tuple of 3 integers, an array of 3 integers, and a slice of integers. Note that the implementation for a tuple and array will be checked at compile time, but a slice implementation needs to check at slice length. Also note that correct RGB color values must be integers in the 0 to 255 range. We're still doing I16s though. Okay, just a sec. I have to text my wife here. Yeah. Okay. Try from tuple. So we're doing a conversion into color. And color, what the type? Oh, it's U8s. So we have to say badlen and int conversion. Okay. And they're I16s. So we have to check the range. If tuple dot 0 is less than 0, or tuple dot 0 is greater than 255, and then we have to do that for 1 and 2. then we're going to return a self error bad. Oh, int conversion. Otherwise, we know they all will work, so we can return an OK of color of tuple 0 as U8, tuple 1 as U8, and tuple 2 as U8. Right? Let's just put errors here. Just to get the code to compile. I'll put that there and put that there. Oops. Use structure. Oh, they're red, green, and blue. I'm assuming it's red, green, and blue for the tuple as well. I forgot this part has to change. There we go. Okay. So we have 4 tests, but that 4 tests failing, but that's because I didn't do these guys. Okay. So now we have to do the same thing except with a slice. So instead of tuple of 0 like this, it's like this. Right? And instead of tuple, it's array. Right? Oh, and that fits all in one line. Okay, so we're down to 3. Slice correct, slice excess length, slice insufficient length. All right, so this is where we're going to return the errors. Bad len. So if slice.len is less than 3 or slice, no, just not equal to 3. Return bad len. Let's just return that too. U8 implements try from, so after you've done this, you can also try to use the trait instead of making the equality. Right, right. The thing with the try from though is I'd have to do the map error, right? But sure, we will. Yeah, let me try that. Okay, so this is slice correct. Yeah, because we're not doing any of the work now. Okay, so now we know that it's 3. So we can do this. And then change all these R's to slice. Yeah. Okay, so let's try what MouseX is suggesting. We can just use try from on I16. Oops. Right, and standard convert try from. So we can just do it this way. So we can say U8 : try from tuple. That's the syntax. Can you iterate over tuple entries? Because then we could just yeah, so I would have to say like this: let t0 is equal to tuple dot 0 U8 try from map error. It takes a closure, right? Self error int conversion. Oops, too many R's in error. It should only be 3, and I put 4. Yeah, so we can do each one of these, right? And that saves all of that, and then we can just get rid of that. Oh, then these have to be like that, right? Oh, we don't need the U8s anymore. Oh, actually, even easier. Red, green, blue, comma, comma, comma. Oh, and I did this wrong. 1 and 2. Boom. Okay, so that's a lot simpler, right? And then we could do the same exact conversion here. It would just be copying these guys. Oops, gotta put it there, and then instead of tuple 0, it's array ARR. And then go like this, and go like this. Yep. And then finally, this is exactly the same, except for we're going to leave that slice check in there. Slice length check. Get rid of all that. Boom. Okay. Yeah, I think that's cleaner. And then if you wanted to, you just make a macro, right? We had that before. Macro rules, convert, and it could just do this. And I don't have time. I'm running out of time, and there's 2 more exercises left. So I want to see if I can get the last 2 done before I have to end the stream. Okay, asref mute. Asref and asmute allow for cheap reference-to-reference conversions. Read more about them. Obtain the number of bytes, not characters, in the given argument. Obtain the number of characters, not bytes, in the given argument. Squares a number using asmute. Add the trait bound as is appropriate and implement the function body. So we need to add a trait bound. And they're already suggesting, for byte counter anyway, and char counter, to add as refs. If I say arg times arg, right? Will it tell me what trait bound I should add? Yeah. So I can add this as the trait bound, right? Can I just do that? Or do I have to do the whole thing that they're saying? Standard optimal. No implementation for box U32 times box U32. Oh, and then I have to deref it? This we know we need to add as ref. And we need to add as ref here. Oh, as ref. T as ref T? Oops. Oh, now it's getting even worse. I obviously don't know what I'm doing here. Okay, so let's ignore those changes. Ausek says you will have to use a where clause because within brackets you can only put bounds on the type of T, not the mute thing. Oh, okay. So let's get rid of this thing here. So I do have to use this where clause. And now we have lifetime issues. Use standard ops mul. All right, and then we have t as ref. So they're saying add t as ref here. But I don't think that's the whole answer, right? Oh, I have lifetime issues because I'm trying to return a result. Ah, thank you, MouseX. So I got to do that. No, it's still saying explicit lifetime required. Oh, numbers. Oh, this is supposed to square the number in place, not return a squared number. So we should say arg times equals arg, like this. So let me comment these two lines out, because this is what it was before. And it's still saying, oh, mul assign. Okay. Let's see if that... And now it's saying this has to be static. Oh boy. Yeah, so I'm at a loss on this one, huh? I'm going to dive into the add as ref stir as trait bound to the functions. Really? Is that all I need to do? Mosaic says, anything that's not perfect will get you on the lifetime hell ride. I'm definitely there. I'm definitely on the ride here. Okay. But this should be solvable. If we do this and I get rid of this. I mean, it doesn't matter if we do mul versus mul assign. It should have the same issue with lifetimes, right? And it's saying I need to do a static. Can I just put TK here and add it everywhere? Or would that still fail? It's saying everything has the same lifetime. Nope. Welcome back. And what we were doing last time was the final. We got 91 of 92 complete on this Rustlings thing, and we just couldn't get this last one. And this is where I left it, kind of with this kind of mess here. I'm going to reset it back to the way it was. I think it was without the where clause, and this was just nothing, right? And that's all this was. You know, we should take a look at Where did I have the rustling stuff? Oh, it was in a different window. It was over here? Ah, yeah, it was over here. Okay, so let's move these windows where they belong here. And where's Rustlings? Thought I had Rustlings. Oh, I do. It's just over here in this other one. Okay, here we go. So, yeah, let's just go back and we'll take a look at exercises, its conversions, and its as-rev mute. So this is the way it looked. Oh, with question marks. Okay. Just to get it to stop compiling or something. So if I just reset it back to that, right, and then we leave the test alone. So the test just has, can we square a boxed number? And this is still, I still don't know what the answer is. Oh, did I not reset it properly? Oh yeah, so it's just a t. Okay, so let's do that. And it's going to complain about t not having bounds or something like that. Oh, it's just that we can't multiply. So, okay, so, right. Then what we do is say, okay, arg is equal to arg times arg. Okay, so it's probably not easy to see, but this is a green asterisk and this is a yellow asterisk. So Rust Analyzer is able to tell the NeoVim the difference between a deref and a multiply. And then this fails because we don't have standard ops mul. If I just add that doesn't work, right? Because now we have issues with expected parameter t found associated. We're supposed to be adding the as mute thing, not the mul. So I don't know, maybe as ref. I mean, I can add this also, right? Standard ops mul output equals t. We shouldn't need both, but I guess we do. Right, and then no implementation of for box 32 times box 32. Required by this. But I want t also to be as ref something. I don't know. Say box t. Nope, that's not how you do it. Oh, I put the because this needs to end here. And then we got too many of those, yeah. And that doesn't work because we can't, even though I said it has to be an as ref, maybe I have to put it first. The order shouldn't matter, right? Get this thing to compile. Oops. Yeah, the order doesn't matter. But it's saying that required by this bound. Oh, asref box. Oh, okay. So maybe I just say asref U32. Nope. Well, we have fewer errors, but now we have still a problem. We can't multiply a box by a box. Okay, let's take a look at this page and see what this has to tell us. Used to do cheap mutable to mutable reference conversion. This trait is similar to asref, but used for converting between mutable references. If you need to do a costly conversion, it's better to implement from with type &mute or write a custom function. Note, this trait must not fail. If the conversion can fail, use a dedicated method which returns an option t or result t. And I can't implement a from, right? Because I'm not defining U32 or box. So I can't say impl from box U32 for U32. Right. I can't do that, but it should already be able to deref. A box should be able to deref in a box U32 should be able to, sorry, a reference to a box U32 should be able to deref into a box U32. Oh, What type is this? This is mut T. It just says mut T. I can't just do as ref, right? Like I did up here. Like I did up here, all I do is add as ref. Now I can't multiply these things. I'm saying it has to be a multiplying thing. I could try just as ref U32 on its own. And that doesn't work. Right? It does define T to be an as ref like that. Here it's saying T is an as ref stir, and an arg is just T. So this is an as ref U32. I mean, it's mutable. Do I have to do something mutable? No, now it blows up. Oh, no, because of lifetimes. Yeah. So is there an example here? As mut U64, num mut T. So I shouldn't need that. So I guess I don't know. Oh. So we can add one, but we can't deref it. Do I have to as ref? Oh, I did as ref. This should be as mut. So if I say let value is equal to arg, does it know it's a U32? It doesn't. If I say U32, here it does. And then can I say val times val? Expected U32 found type parameter T. Yeah, so it thinks it's a T, but it says as mut as ref, right? So if I say it's an as mut U32, as ref U32, I should be able to deref it into a U32, but it's saying I can't. And I can't because this type parameter is T. I guess they're just expecting a T here, right? And that's what this ends up being. And then can I do it also with a mul? Expected type parameter T found associated type. Now it's saying no implementation. So we're back to the original error. So I don't know. I don't know what this example is supposed to be doing. If we do this, this should work, right? If I copy paste this in here. And make this a test. Boxed anchor. Right, this test should pass. Let's comment this out for now. Yeah, let's comment this out for now. So we don't have to worry about it, and then comment this one out for now also. And then maybe what we can do also is look at the diff. So this is the add one example that came from here. So this should work, right? Yeah, so this works. And all we're doing is putting as mute U64, and we're adding a 1. But that's because we're not deroughing this. So it's a very simple example, but it shows that you can do an as mute. And we should be able to do, right, we can make it 9. If we put this test back in and just assign get rid of all this and just put as mute. Right? And then just assign 9 to arg. That should work, right? What's the difference here? What's the difference here? Oh, I have to do as, there's an as mute. Oh. Okay. So if I do that, I have to deref it and then call as mute on it. Sorry, that works. So can I do arg times arg now? Or do I have to add the multiplier? Yeah. So let's try that. I don't know how my eyes just glossed right over this. Almost there. Okay. So let val equals this, and this is U30. That's a U32. Okay. Oh, but it can't generate an implementation for it. Right, it can't generate. It can generate an implementation for something that's mutable. I have to say arg as ref. Oops, I don't know what I did there. Oops, and then this needs to be a semicolon here. Method cannot be called on mute t because of unsatisfied trait bounds. Right, so then I can add as ref. And still no, yeah, so it has to be able to multiply. So that comes from here, being able to multiply them. Maybe we can get rid of that. Ha! So, okay, so can we just do it in one line without the introducing an extra variable? That's it. Okay. So we have an answer. That's interesting. We had to deref it here using asref, and we had to mute it using mute. But we finally got there. Wow. How long did that take? 15 minutes? I'm going to edit this down. for the YouTubes. Okay, I think that's it. That's the last exercise, right? And we're all done? Huzzah! We're all done. All exercises completed. You made it to the finish line. Get it? Because Fe is iron, and iron rusts. We hope you enjoyed learning about the various aspects of Rust. If you notice any issues, please don't hesitate to report them to our repo. You can also contribute your own exercises to help the greater community. Before reporting an issue or contributing, please read our contributing guide. Okay. I added an exercise. Update an outdated exercise. Report a bug. Open an issue. Fix a bug. Open a pull request. Yeah, there were a couple of notes I took, right? Where did I put them? Up here? Yeah. Just some typos on line numbers. And, oh, I wanted to look up what non-lexical lifetimes were.